Device Nation Academy 2026 here in the Big Easy. Ben Holmes, Nanochon.
How you doing?
I'm doing awesome, man. Don't feel the pressure with all they're all grading your performance here, but it's all good. We're here to support you and to bring y'all's story to Device Nation. So I got a little sneak peek of it the other day. I think it's super cool, super different, super interesting. Before we get to the demo, a little bit of the backstory, right, of how we got here.
Yeah, absolutely. So my co-founder and I were academics in a biomaterials lab working in bone and cartilage. My dad was an All-American athlete who complained of knee problems his entire life. And also my co-founder, Dr. Castro, himself has suffered multiple sports injuries. So we had a lot of personal investment in trying to find a better solution for treating cartilage. We were working a lot with synthetic materials, and so what our product is it's an implant made of this proprietary synthetic material that we developed, which is designed to actually mimic the collagen fibers that exist in cartilage. So fully synthetic, but it has this collagen-like structure. And then we use 3D printing to actually make the final device. We're not doing patient-specific, so we're not scanning the knee and making a device just for the patient, but 3D printing allows us to make this further level of complexity, basically taking that material and turning it into a scaffold. But it also means that we can preserve the mechanical integrity of this device. So really what it does is it acts as an immediate load-bearing replacement for the lost or damaged cartilage, but then it also acts as a scaffold to regrow cartilage over time. And we achieve that through the engineering of the material and the structure, but we don't have drugs or cells or allograft tissue or any of the things that make the current solutions expensive, unreliable, hard to use. One of the other things we're very proud of as well is that this is a high performance material. So it's very easy to handle. If you want to pass it around, these were opened up a few moments ago. Robust but compliant. So if you think about actually handling this in the OR setting, very forgiving compared to an oats graft or some of the biologics or what have you. And it's very easy to install. We developed a procedure which is very analogous to an oats or an allograft. Basically, we've got a guide wire, we've got this sizing and alignment guide, we have this punch to score the cartilage, we have a reamer, and I'll kind of explain how that works, and then we ultimately have this introducer tool as well. So if you think about doing this procedure, you've entered the joint space, whether it's a mini open or arthroscopic, because these tools were designed for arthroscopy in mind as well. You would identify your defect with this tool. This platen on the end of the tool actually has the exact dimensions of the device. So you know that that's the footprint of the device you're going to install. And then afterward, you can use it as a trial, which I'll kind of explain. But let's say there's a defect here. You'd find the defect, you drill your K-wire through that cannula in the middle, you'd remove it, you'd come over top with the punch, you come down, and this is not something that you have to tap, but just rotate lightly, just to get a nice margin in the cartilage so that the reamer can do its job. Then you'd come in with the reamer. Now on the end of this blue plastic piece, that's a depth stop. That will ensure that you're always drilling at the appropriate depth. Come over, drill, remove. Now this is what I meant when this is a trialing guide. Once you do all that, you can come back in. This platen also has the thickness of an implant. And we are recommending that the device be recessed about 1 millimeter under the level of the cartilage. So you'd want to come in and check it and just make sure that you're in appropriate depth to make sure that implant is properly seated. Remove that again. Then you would drill out your K-wire and remove it. And then the final step would be either, if it's a mini open, you could press the implant in with your thumb and you actually hear like a nice click. But this introducer tool also makes arthroscopy, very, very easy. So very simple. This isn't a spring-loaded mechanism, but you see there's a button right here. So you press the button, and all that does is it releases this sheath so that you can engage that little tamp there, which will push the device in. So again, it's really just the force of your hand, and then the sheath as it hits the surrounding cartilage is being pushed back into the handle. These come prepackaged, the actual devices, so they're not preloaded into the tool. You have to open one up. You could have your scrub tech or your OR assistant, opening that up on the back table while you're doing the reaming. And then the device just loads easily into the tip of this introducer like that. So you can see about 2 millimeters of the device are protruding. So if you think about coming into the joint space, you know, you'd line that up with the hole that you reamed, you kind of line it up, and then you can engage and push it in. And then you can see here in a Sawbones, we have a device that has already been installed. You'd like to pass that around and kind of see, but you can see what I'm talking about, where we like to have a little bit of a 1 millimeter recess. And that's really important, not because the device isn't mechanically stable, but that's important because it leaves room for cartilage to grow over the top. You know, what we've seen in our animal studies most recently was a horse, is that you get very high quality hyaline-like cartilage kind of growing all through that 3D printed structure, and you also get cartilage over the top, as well as subchondral bone underneath the device. So that's the longevity piece that we're excited about. We've currently initiated our first human study in Canada, so that's kicking off right now. But we are looking to start recruiting physician partners to be investigators in the randomized trial, which we hope to start later next year. So if anybody watching this is interested in participating in the trial, please find us.
So you put it in with this side down, the recess side down.
That is correct.
And do you ever load it with any, say, blood, clot, something that biologically would charge this more?
So what we've seen in these animal studies is that the device alone is able to wick up blood from the subchondral bone. So the reaming procedure makes the blood, come. So, we're not specifically recommending that. I'm sure people are going to practice medicine how they want to. I don't think it would disrupt anything, but
have you used a mallet on the end of your inserter yet?
We have not tried that yet. I'm sure people will think to do that.
Yes.
Surgeon will certainly hit it.
Yeah.
We have to.
Yes. What I will say though
not
is
sitting down properly, like it goes in a little askew. We have to fix that, and sometimes we use a little bit of force to coerce it. So make sure these toys are kid-proof.
Understood. Yeah, for sure. Yeah, that makes sense.
Is this the largest size of defect you can address?
Yeah, so right now we have 3 sizes, a 10 millimeter, a 15 millimeter, and a 20 millimeter. I think beyond that, a surgeon would probably want to use multiple devices, especially when it starts to get really elongated. But we sort of found this is probably the largest circular shaped defect we're going to see.
Not being a sports guy by any means, but can you do the little snowman thing where you stack them up? In oats if you got a big
mosaic,
defect.
like a mosaic
Yeah.
plastic.
Yeah, that's something we're currently evaluating. In the first in-human study, we're not allowing that, but it's something we kind of have our eye on as a use case.
And the other thing, when you use a allograft, kind of match, and on the larger sizes, matching curvature is an issue, and these are all flat.
Here's why they're flat. Tissue is going to grow over top of it. The tissue matches the anatomical curvature. So that's how we have solved that problem.
And you have studies
Yeah,
showing pictures of that?
Yes,
And histology of,
yes,
of the
histology
cartilage?
from a 12-month horse study, and also several other animal models prior to that. Yeah.
So I call it like oats 2.0.
Well, we think we're oats 3.0, but
And you're not making holes or creating morbidity for the knee by
That's right.
taking it from somewhere
That's
else.
right. Don't poke anybody's eye out, please.
That's what the rep wants you to
There
do
you
in the
go.
room. That's going to happen in the OR.
Oh yeah.
Reps love that.
I don't put it down for making
You got to bring Mr. Ed into here, right? If it can handle that, then it can certainly handle me, right?
Absolutely, yeah. And again, one of the reasons why we chose the horse, it's a very robust demonstration of what the technology can do.
Right.
Yeah.
Right. Cool stuff. Any other
So it's just
comments,
mechanical
questions?
fixation into
Yep,
it.
just mechanical fixation, just
fit.
press fit. Yep. And again, that's an element that was highly
Is the,
engineered as well.
diameter of the hole a tiny bit smaller, so it's line to line. Really.
Yeah, it's more or less line to line, but if you look really closely, there are these very fine features. You can kind of see like a ring. That ring protrudes like a fraction of a millimeter, so it does actually create an interference fit, which is very slightly.
Really Thank you, Ben.
Yeah, thank you. Thanks for stopping by.
Yeah. So, huge thank you. Device Nation thanks you. We all thank you for it's a risky thing getting in front of a camera, right? and sharing what you're excited about with the world. So we're excited for you, for Nanochon's future, for people that are watching this, Ben, that want to follow along, that are thinking, you know, maybe I'd like to enroll in that study once it comes to the States. How do they reach out to you guys?
Yeah, so it's very easy. Just go to nanochon.com. We have a patient portal for interested patients, and we also have a clinician portal for those who are interested in trying the device or being investigators.
Really appreciate you letting us into your booth today, Ben. Wish you great success
My
here
pleasure.
in the Big Evening.
Thank you.